Block A of mass m and block B of mass 2m are placed on a fixed triangular wedge by means of a massless inextensible string and a frictionless pulley as shown in the figure. The wedge is inclined at 45 degrees to the horizontal on both sides. If the coefficient of friction between block A and the wedge is 2 by 3 and that between the block B and the wedge is 1 by 3 and both blocks A and B are released from rest, the acceleration of A is to be calculated. Since block B is more massive than block A, block B would tend to move downwards and block A would tend to move upwards. Since the string is inextensible, both their accelerations would have equal magnitude. Tension in the string can never be 0, and any solution that mathematically gives us tension less than 0 is physically unacceptable. Also, when both blocks are at rest, the acceleration of the blocks cannot be in the direction of friction, because friction would always oppose relative motion. With these concepts in mind, we can write the governing equations for the motions of blocks A and B as follows. The net force acting on block A is ma, and this in the uphill direction. This is equal to tension in the string minus component of gravity that is acting downhill minus the friction acting on block A. This gives us tension is equal to ma plus mg by root 2 plus fa. Now it's clear that tension can never be less than 0 even mathematically in this case, and therefore we don't have to keep an eye out for such an erroneous solution. Now writing the equation for block B, we have the net force acting on B is equal to the component of gravity acting down the slope, which is 2 mg sine 45 degrees minus tension minus friction acting on block B. Substituting the value of tension which we get from the first equation into the second equation, we have 2ma is equal to 2mg by root 2 minus ma minus mg by root 2 minus fa minus fb, or 3ma is equal to mg by root 2 minus fa plus fb. Now what are the limits on the frictional force? The frictional force acting on A is always less than or equal to the coefficient of friction multiplied by the normal reaction between the block and the surface. Similarly, for block B we have the coefficient of friction times the normal reaction between the block and the surface. Therefore, the sum of these two forces, Fa plus Fb, would be less than equal to 4 by 3 times mg by root 2. In this equation, we can see that Fa plus Fb can have a larger magnitude than this term, mg by root 2. But since we already discussed, that is not physically possible, as friction opposes relative motion, and if acceleration is negative, that would mean relative motion is in the direction of friction. Therefore, friction would just be strong enough to avoid any acceleration. Therefore, the answer would be option D. Acceleration of both the blocks is equal to 0.